So we'll write that over here. We have MT, or we could call it TM, either way. Congruent to EP, or we could call it PE. All right, then we have our last side. We have this AT. So that one's going to get those 3 tick marks. And that's going to be congruent to this KE that also gets 3 tick marks. So what this theorem is saying is if we see a picture like this, remember in order for 2 triangles to be congruent, we have to look at both their sides and their angles. But what this theorem says is if we have all 3 sides matching, there is no other way to make that triangle other than for it to be exactly the same. So even though we don't have those angles marked, we know that those angles will end up being congruent because all the sides match. So that's our side, side, side. So we're going to write out that congruence statement. I'm just going to use my pencil now. So triangle. We'll get really good at drawing that triangle symbol. And what that means is that we have these 3 points and they make a triangle. It's not just a plane. Okay, the first triangle, it doesn't matter the order we put those points in there. We can do it whatever order we want. So we could do ATM, MAT, MTA, TAM. What do you guys want for that first triangle? ATM. Now when we do the second triangle, when we write that congruent symbol, that's where we need to make sure it's lining up. This one's going to be really important. So for the second part, we're going to follow how we worked through this. So we did ATM. So we did our red, green, and then at the end would be the blue. So we did the 3 tick marks, 2 tick marks, 1 tick mark. So where do I need to start with over here? K. All right, now for K, do I need to go K to P or K to E? Here we did A to T, so we did AT. So here I have to do K to E, yep, and then down to P. So it's really important that we're following those tick marks that we're doing. All right, now in math people are very genius about how they name things. This was called side, side, side. Because how many sides are we doing? 3. Now, the way we abbreviate this is even more mind-blowing. We're going to call capital S, capital S, capital S. So we have side, side, side. Okay, and I'm just using the same colors as my sides here. They were all sides, so it doesn't matter which color is which. Alright, I'm going to go down to this side, angle side. Nah, let's do angle side. I liked how we did it in period 2, 1. It doesn't matter. Alright, angle side. We're going to go to this one. Now in this one, based on the name, are we going to have all 3 sides the same? No, what are we going to be working with this time? 2 angles and a side. Crazy, right? Alright, so as we look at this, let's start with our angles. Okay, we have 2 triangles. One's kind of on bottom, one's a little bit more on top. To start off with our angles, I'm going to start with angle J. So I'm going to do an arc there. And angle J is going to be congruent to angle E. Now, for J and E, I can just do one letter, because if I say angle J, is everyone going to look at the same angle? Yeah, how many angles are there with a vertex of J? Just one. So because there's only one there at J, we can just call that angle J. But for the second one here, we're going to look at this angle D. If I say angle D, do you know which angle I'm talking about? No, because there's actually three. There's the small one, and then the one all together. So we're going to look at kind of this bottom one. It's part of the bottom triangle. We'll do two arcs there because it's different than the other angle. I also switched colors. And that's going to match up with this angle at the bottom. That didn't line up perfectly, but that's okay. And those two are congruent. Now, because there's more than one angle at these, how many letters do we have to use to name those angles? 3 letters. Yep, it's like we have to outline it. So for this first one, if I was going to outline, I would start either at J or Y. I like to start at J. So I would do J, then go where? I'd go up to D, where the vertex is, and then down to Y. So angle J, D, Y. Now, the order that we put those letters in doesn't matter. The big thing is that vertex has to be in the middle. So now for this one, what would be the name of that angle? E, what? DYE or EYD? Yep, either one would be fine. I'm going to go with EYD because that's just the way my brain looks at it. But if you want to do DYE, that's fine. Now, in this problem, we have 2 angles and a side. The side is after the angles, so we can't use the angle in the middle, or the side in the middle. We're going to go around. But in this case, the way that this shape is set up, there's a side that is congruent on both, because they both share a side. Which segment is on both triangles? Yeah, that segment that goes through the middle, that's a part of the bottom triangle. And it's a part of the top triangle. So it's congruent to itself. For some reason I like to do 2 tick marks when there's the one in the middle. Always it looks silly to me. You could do 1 tick mark or you could do 5 tick marks. It doesn't matter. So we're going to say that dy is congruent to dy, because if I pulled those triangles apart, if I took these two and I separated them, that dy did match, so we know that that length is going to be the same, which means that they are congruent. That was way back in 2.6 that we learned that property. Technically 2.6 part 2. That was when we learned symmetric, reflexive, transitive. So think to yourself for a moment, don't say it. dy is congruent to dy, so we have the thing is congruent to itself. Which one of those properties, symmetric, reflexive, or transitive, says something is congruent to itself? Symmetric means to flip around. Reflexive, because reflexive is kind of like that word reflection. When you see yourself in the mirror, or reflection, it's a reflexive. Alright, now we're going to say our triangles. We'll come up with our congruent statements. So triangle. The first triangle doesn't matter the order we put it in. Ari, give us one of the triangles. JDY. Perfect. As long as you use those 3 letters, you can't screw it up. Now, the second triangle, we're going to be really careful about how we say it. We want it to match with that JDY. So J was the one with the 1 arc. Then we went to D with the 2 arcs. And then we went across to Y. So if we started with J, what should I start with on the other triangle? E. Do I want to switch the Y and the D around? Or should we do EDY? No, yeah, Y. Because that D has the 2 arcs. What has the 2 arcs over here? Y. And then we end up on that side that's the same, and we get D. So is it okay that those flip-flopped around? Yep, that's totally fine. Alright, I'm going to remember that I did so I have green, my angle, red, an angle, and then blue is my side. So I'm going to go green, red, blue when I do mine, just to match. And for an angle, instead of using an S, what letter might we use to represent an angle? A. So I'm going to do an A, S. And I'm just doing it in the same colors as I color coded it. So I had my angle, my first angle is green, second angle is red, my third part was the side that was blue. So I did AAS. If that color coding doesn't matter to you, then I guess don't do it. Alright, we're actually going to go down 1. Alright, the one below it says angle, side, angle. So how many angles are we going to be working with here? 2. How many sides? 1. So what might be the difference when you look at those names? How is the second one going to be different than the first one? What do you notice about the positioning of the words? They're different. One is where the side is at the end, and the other one, the side is in the middle. So that's going to change how we look at that diagram, because the side is going to be sandwiched between the 2 angles. We'll talk more about that as we look at it. So we're going to start with an angle. So let's open that one up. We're on this one, on the right side. So as we look at it, there is one angle that we already know is congruent because of a theorem. So take a look at that. Which angle from the left triangle to the right triangle do we know is congruent to itself or each other? B. Why at this angle B, why are these 2 congruent? Good, vertical angles. They're across from each other. And vertical angles are congruent. Now, if I say angle B, do you know which one of those angles I'm talking about? Everyone look at angle B. Which one am I looking at? I'm looking at the bottom one. Tricked you. Okay, hilarious. There's lots of angles there. Alright, so because there's lots of angles, we have to use how many letters to identify that angle? 2 would be a side. 3. So if I want to name this left angle, how would I name that? QBL, or we could do LBQ. As long as B is in the middle, we're tracing that out. Alright, is congruent to angle, what's the other angle? XBF or FBX. Alright, we do have a lot of notes today, so when you come back from lunch, we are going to ask that you sit in your still assigned seats as we work through this. This is a really, really important lesson because we're going to be doing so many proofs with these things. Alright, so this one was angle, side, angle. And we said that that side has to be coming from that angle. So from that angle that I said was congruent, we're going to mark one of the sides. So let's do QB. Is going to be congruent to BX. Alright, so that side QB is congruent to the side BX. Alright, that should be put away. You should be refocused. Remember, this is a really important lesson to have these done. Alright, now the angle has to come right after the side. So let's go angle, follow that side, go directly to the other angle. So which angle would sandwich that side QB? Is it going to be angle L or angle Q? Q, yep. Angle Q is going to have that, so it goes angle, side, and then it goes back right to that angle. So angle Q is going to be congruent to angle X. And again, this is nothing that you are necessarily finding right now. This is all things that are given to you. We're just learning how to identify these. So angle Q is congruent to angle X. Then we're going to write our congruent statement. Our first triangle, doesn't matter the order we put that in. Uba, will you name our first triangle for us? O, Q, B. Perfect. Alright, so Uba did that first one for us. So second one, we have to match with how Uba named that first one. So we have L, Q, B. So when you go to that next triangle, what's going to match with L? F. Yeah, it's the only one that's not marked. Okay, then we went to Q. So where am I going to go after F? Should I go to X or to B? Yep, X. And then I end up at B. This time those B's end up in the same place. That's okay. Do they always end up at the same place? Just because they're the same letter doesn't mean they have to end up at the same place. This time they did. Alright, so I did my side in green, so I'm going to go blue, green, red when I label this. So this is angle, side, angle. Blue. Alright, we have one more like this, and then there's one that's kind of one that is a little bit different than the others. And we're going to talk a little bit about some tricksters, ones that don't actually work, that will try to show us that it works, and we'll be like, nah, doesn't work. Alright, so we're going to go to this side, angle, side. So how many sides will we show? 2 sides and 1 angle, and that angle is located between those sides. So it's where the 2 sides come together is going to create that angle. Alright, so this one, do we know any sides that are congruent or any angles congruent right off the bat? No, we don't have vertical angles like that. We don't have a reflexive property where they share it. They're just 2 completely separate triangles. So we have to be based just on what we're given. Okay? So for side angle side, we're going to start with NR. Is going to be congruent to CW. Okay, then I need an angle that goes right next to that, that's connected to that side. So I'm going to go with angle R, because that comes at the end of that side. And angle R is congruent to angle C. Now, even though we're only using 1 letter, because when I say angle C, there's only 1 angle there for us to look at. Could we name that angle with 3 letters? Could we say angle HCW? Yep, we could. Alright, now for the other side, I want the other side to be where that angle connects. So, does that angle connect CW and HW? Or does it connect CW and CH? CH, yep. Nice job, Gabby. So that's going to be, the next side is this one here where it connects that. And CH will be congruent to GR. Or RG, however you want to label that. So what's really important in this one is that that angle is where the two sides come together. Okay, that angle where the two sides come together is called the included angle. So if you're including someone into your group, you're letting them be with you, that included angle is where those two sides meet. They come together. And you just might see that like on your MCA or on your STAR test. It'll be like, what's the included angle? And you'll say angle R and angle C. Alright, for our triangle congruent statement, the first triangle, we get to name it however we please. Samaya, do you want to name our first triangle? C. What? H. And then W. Perfect. First one's no pressure because you get to say it however order you want. Now the second one, we have to match it up. So we did C, H, W. So if you look, we went from C, that angle that we marked, to H, which was the blue side, and then over to W. So which angle should I start with here? Which point? R, because R matches with C. Then what's going to go with H? G. And then at the end, we'll get N. Surprisingly, that's how my last class did it too. Weird. Alright, this one I have, red is my included angle, so I'm going to go green, red, blue. And this is side, angle, side. So if we see this, as a side angle side that's congruent between the two of them, we can say that the two triangles are all congruent. All those angles, all those sides actually end up being the same. One more theorem that we're going to talk about. If you notice this side angle side, what do you notice about that first S? It's capital. Good job. Nice job. It doesn't matter that that S is capital. No, that was a mistake on my part. Whoops. I just wanted them all lowercase, but that one just got capital for funsies. Correct. Alright, this next one we have hypotenuse leg. Now that word hypotenuse we only use with certain types of triangles. If you take a look at side, what kind of triangles are we working with this time? Right triangles. So this theorem only is with right triangles. So I'm going to write that first on the slab. Right triangles only. It only works with right triangles when you have that 90-degree angle. Alright, we're going to start with our hypotenuse. This is a hypotenuse leg, so we're going to identify our hypotenuse. Hypotenuse is H-Y-P-O-T-E-N-U-S-E. It is Latin root, but the Grecians, I think, came up with it. I don't know. I might be lying. I know the Greeks really liked right triangles. They did a lot of right triangle trigonometry. We're going to talk about that so much in Chapter 8. Okay, the hypotenuse is the side that's located across from the 90-degree angle. So when we look at this 90-degree angle, we're going to travel across the triangle to the other side. So in this one, we're looking at CZ. I'm going to just do 2 tick marks. I don't know why. I just decided to for funsies. Okay, so CZ is going to be congruent to... Which one is the hypotenuse on this triangle? It's the one across from the 90. The UT, UK, KT, UK, yep, across from that 90. So this is that other hypotenuse. So the hypotenuse would be C is congruent to UK or KU. All right, then we have the leg. A leg, it just means one of the other sides. Okay, triangles have legs. I was going to say legs have triangles. Triangles, I think the reason why is because there's 2 of them, and humans have 2 legs, so triangles get 2 legs. I don't know. But they're called legs. It doesn't matter which leg we mark here for our purposes, but remember this is more used for identifying. So let's do WZ. And based on looks, which one is WZ going to match up? KT, yep. Katie who? Get it? KT? Katie? Hilarious.
The legs are just the 2 sides that are not the hypotenuse. Okay, so either of those will be called legs, whatever 2 sides are not the hypotenuse.
If you want to write that in there, you could write leg, leg, hypotenuse. You could do it on the other one, as I'm going to just do it on one. All right, let me just have our congruency statement here. So triangle. First triangle, doesn't matter the order. Cody, give us the first triangle. What would you like? UK?
What?
What did you say? TUK. You're missing a letter. TUK. I don't know why I wrote it there because I don't have a lot of room. That was a bad choice on my part. Triangle. So we did TU to K. What matches with the T in this triangle? W. And then C. And then Z. I don't know why I wrote it so weird, but I did. My bad. Alright, last flap we have is the tricksters. Tricksters are things that do not work. Okay, they're ones that we might see a diagram where they're marked this way, but just because the diagram might look like it's congruent, we can't say that they are congruent. Oh, just kidding, we have to label this first. HL. Sorry. Hypotenuse, leg. I did my hypotenuse in green, and I did my leg in red. Alright, last one is tricksters. Tricksters are ones, again, where they're going to have things labeled, and it might ask, are these triangles congruent? And if you see one of these tricksters, you're going to say, no, we don't know that. We would need more information. One of the tricksters is angle, angle, angle. At this point in our life, can we do A instead of angle, angle? We know A stand for angles. So if all the angles are congruent from one triangle to the other triangle, that doesn't necessarily mean the triangles are the same size. Okay, it means that we have those same angles. The other one that's not going to work is side, side angle, which is a little bit different than the side angle side. Remember, side angle side, it's the angle where the sides come together. Side, side angle would be like a side, and then an angle that's not included. And the reason why that one doesn't work is backwards. Okay, you're right, but it's how we like to remember it. Shh. We don't like ass. Okay, the reason it doesn't work is because that angle in between the sides can vary greatly. And so just because one of the angles is the same doesn't mean that, because if that angle switches in between, then the side will switch. So these do not work. So if you want to like circle, cross it out, so you can still see it, don't like scribble it out because you do want to see what they are. But these do not work. Alright, if you did not get that glued in yet, that is your step number 1 now.